Welcome everybody to our next talk. It's the talk Wallet Fail. As you all know, when you have something valuable, you put it somewhere safe. But as we as hackers also know, there's no place that is really safe. And our three speakers, Thomas, Dimitri, and Josh, are now going to demonstrate in the next hour the art of completely breaking something apart. So please give a big round of applause for Thomas, Dimitri, and Josh, and have a lot of fun.
So just to start, I'm curious how many people here actually own cryptocurrency? Raise your hand. And how many of you store it on a hardware wallet? So we're very sorry to everyone who has their hand up. Okay, so it's not just me, it's me, Josh, and Thomas. So we're all hardware people. We do low-level hardware stuff in varying degrees. And we got into cryptocurrency, and so I can recommend to everyone sitting in this room, if you're a security person, there's not a lot of people doing security in cryptocurrency, as much as that's painful to hear. So yeah, I mean, a lot of this is based on reverse engineering. We love cryptocurrency. I mean, for us, crypto also stands for cryptography, not just cryptocurrency. But no offense to anyone with this talk. It's just something that it's a category that we looked at, and so the results kind of speak for themselves. And again, this wouldn't be possible alone, so we have a lot of people to thank. I'm not going to go through all of them individually. Just be known that we're thankful to everyone on this slide. So we started this about 6 months ago. So we wanted to take a look at cryptocurrency because we own some cryptocurrency ourselves, and we saw that everyone's using cryptocurrency wallets. It's more and more the thing that you do. So we started a group chat, as you do nowadays, and we have 50,000 messages now and 1,100 images, and I had my first, I had my son in the meantime as well. So it's a really long time that we spent looking at this, etc. Okay. So what do we want to achieve though? Because people don't give the kinds of attacks that you can actually perform against cryptocurrency wallets and of credit. So first attack is supply chain attacks, where you are able to manipulate the devices before they get to the end customer. Firmware vulnerabilities, where you find a vulnerability in the firmware and can somehow either infect or do something else with the device. Side channel attacks, of course, I think that's one of the more obvious ones that people are familiar with. And also chip level vulnerabilities. So we were able to find one of each of these, and so that's the talk. We're going to talk about each one of these individually. So, but first, what's a wallet, just in case you are not 100% familiar with them. So a wallet, and in general, cryptocurrency, how do you do this? It's just asymmetric cryptography. So you have a private key and a public key. The public key, basically, it gives you the address. You can derive the address from this. The address is nothing other than the public key of the wallet, and you have the private key, and you need this to send transactions, so to actually operate with the cryptocurrency. So this, the private key, is what needs to be kept secret. The public key is something that everyone can know so that they can send cryptocurrency to you. But it kind of sucks to have separate for each cryptocurrency pair, or for each wallet. Maybe you want multiple wallets. It sucks to generate a new cryptographic pair for each one of them. So the wonderful people behind Bitcoin have thought of something for this, and it's called BIP32, BIP44. And so what it is you have a cryptographic seed, and you can actually derive the accounts from a single seed. So you basically store one seed, and you're able to implement and do unlimited amount of wallets. Okay, so basically you do key derivation, you add some data, do key derivation, and you can have an unlimited amount of wallets while storing a single seed. And this is what you're using when you're using a hardware wallet. So, and of course, for each key derivation, there will be a new private key and a public key, but it'll be generated in a predictable manner, and you only need to store one secret seed. So you only have to store the seed. You can write it down, and that's the advantage. But it's difficult to write down because it's binary data. So come BIP39, which is what you're most used to, which is a format in which you can take that cryptographic seed, that binary data, and actually convert it to a set of dictionary words that you can then easily write down on a piece of paper and store it at your mother's house, or store half of it at your mother's house and half of it at your grandmother's house. And that way somebody would have to go into both houses simultaneously to get your words. So Yeah, so what's a hardware wallet? So we just talked about what's a wallet. So why do you even need a hardware wallet? Well, the problem is, of course, computers can get backdoored, have malware running on them, and this is what you want to prevent against. How do you do this? You have a secure device, you store your seeds externally. Usually this is a USB connected device that you store your crypto on, and so you can trust this even if you can't trust your computer, is the idea. So what happens is the computer sends the transaction to the device. The device gets the transaction, it can actually confirm or deny the transaction. It also displays the transaction. So before you do any cryptographic signing, you can see, is that actually what I was doing, or was my computer owned and is it initiating the transaction for me? So you sign the transaction, and the seed never leaves the transaction, but the hardware signs the transaction for you. You send it back to the computer, and the computer can actually take that and send it to the internet, okay? So that's the quick rundown of how how hardware wallets work. So the first thing that we looked at was supply chain attacks, which is where Josh is going to pick up. You have a mic.
Do I have a mic?
Oh, sorry. Yeah.
Okay. So the three big things I want to leave you with as we go through the supply chain attacks are stickers are for laptops. They are not for security. So we're going to be talking about stickers today. They're for laptop decorations. They're not for security. Supply chain attacks are easy to perform, but they're quite hard to perform at scale. And the last takeaway that I hope you leave you with is that the vendor's threat model may not actually be your threat model. So security stickers. So some of the wallet vendors are using them. I've seen them on other products. They seem to be quite popular. I have a friend and colleague named Joe Fitzpatrick. He also likes stickers. So the stickers that he makes are the same as you would find on a security product. They have holograms, they have unique serial numbers, and they leave you with that nice, warm, fuzzy security feeling. And so Joe makes some funny ones. You can get a FITS 140-2 proof sticker, so you don't have to pay all the money for the FIPS one, just get the FITS one. So the first device that I looked at was the Trezor 1, and so the Trezor 1 actually has 2 levels of protection on the packaging. There's the hologram sticker, and then the actual box is enclosed with an adhesive. So it's supposed to be that you actually have to rip open the box to get into it. But if you use a hot air gun or a hairdryer, it's actually quite easy to remove. And so if you see on the left there, that's the original package, and on the right, this is a box that I opened and put everything back into. And if you look closely, there is a little bit of gap there. The sticker has a little bit of break, but this was a first try and it's pretty close. So trust me, taking a sticker off is not very hard. Now, if you remember this picture of the sticker, because we're going to come back to it. But for the vendor, this is actually a real problem. So Trezor did put a blog post out that one of the challenges they face is that they're facing counterfeiting of their devices. So this is from their blog post. They say, hey, we've noticed that there's counterfeit devices. You have to look at the stickers to see that they're legit. So I said, remember, I'll look at that sticker. So I bought that case about 1.5 years ago for my previous DEF CON talk, and it's the same sticker that they're saying is fake here. So then on their wiki, it's very confusing because there's 3 sets of stickers. So basically, yeah, stickers are very confusing. They cause problems for end users, and I was not even sure if I bought a real Trezor or a clone one. So this morning, I got out a new case, and just to make sure, I took off the sticker using very sophisticated equipment, including a very expensive Dyson hairdryer that was included in the Airbnb, and I was able to remove the sticker. So it comes off without any zero residue. So yes, stickers do not provide any security. On the Trezor T, they switched it from the box, so now the box can be opened easily, but now there's a sticker on the USB-C port. Again, as you would expect, you use hot air and you can easily remove it. Pro tip, don't set the hot air rework that high. I had it set for lead-free reworking and I actually melted the enclosure. So if you're going to do this kind of supply chain attack, maybe set the heat a little lower. But if you just Google how to remove stickers, the same attack methods work. So this causes a bit of confusion because the Ledger device has a very, I will say, in-your-face piece of paper when you open the box that says there are no stickers in this box. However, I combed through about 250 one-star Amazon reviews, and a lot of them have to do with confusion about the stickers. So some of them are actually quite funny. So this one started out note to wallet hacker. So I was really into this. So I was like, okay, pro tip, what's this guy have to say? And basically, he was complaining that there's fingerprints on the device, so that's how he knew it was hacked. Another one complained that the fingerprints were on the wallet and was a hair underneath. So if you're doing supply chain attacks, be sure to remove any evidence via fingerprints or hairs. So anyway, stickers don't work. That's all I want to say about that. Once you get through this enclosure, though, you then have to have the challenge of actually opening the enclosure. These are 3 different wallet devices, Ledger Nano on the left, the Trezor 1, and the Trezor T on the bottom, all of which actually open pretty easily. So the Trezor 1, even, so this, I'm still not sure if that's the counterfeit or the real one, but again, on the real one today, I was able to pop open the enclosure. So it is ultrasonically welded, but you can pry it in there and open it. The Ledger Nano opens very easily, like without any equipment. But once you do this, what do you do once it's opened? So the attack basically is you take the microcontroller and you rework it. So you remove the microcontroller from the printed circuit board and you put on a new one that you bought from a distributor. Once you've done that on the Trezor devices, you put your compromised bootloader on there. So I did not go as far to make the compromised bootloader, but I did confirm that once I switch the microcontroller, I can connect with a debugger over SWD, and I have free access to the chip. So some of the parts got blown off when I was reworking, but the STM runs fine. So yeah, so you just rework, reflash, and then you put everything back together. So next I want to talk about hardware implants. So you may remember the story that came out. There was this big hack by Bloomberg about hardware implants. I wanted to make a hardware implant. I also wanted to have a little bit of fun with this. So we, in honor of the Bloomberg story, which has some, may have some issues with it, we're about to talk about the Bloomburglar, which is a super micro fun implant. So the goals for this implant is I wanted this implant to happen after receipt. So it's both a supply chain attack and a physical one. Like a red team can perform this, a malicious insider could also perform this attack. 0 firmware, because more fun. It has to fit inside of a hardware wallet, so it has to be small. It has to also bypass a core security function, otherwise it's not an implant. Very few components. I have 1,000 of them with me, so I wanted to be able to, for the makers and the DIYers to participate in the hardware implant fun. So, what kind of implant did I end up with? Well, I decided to do basically an RF triggered switch. And so the idea is on these devices, there's a button, and the button is the last line of defense. So all the vendors assume that the host is going to be compromised. They just assume that's going to be easy because that's software. And so once you have a compromised host, you have to send it to the device, and then the human, so humans are still needed, humans have to look at it and say, is this the right transaction or not? They have to say yes or no. So now with this implant, through RF, I can trigger the yes button. So a human is not required to send transactions, I can remotely trigger it. Basically the RF comes in through the antenna, it goes through a single transistor, which is the main component, and it pulls the button low. And I'm sorry to say that the bill of materials is quite expensive at $3.16. $2.61 of that is this potentiometer I had to use, so it's a little bit expensive, I'm sorry. Also, why is this so big? I mean, this is an American dime, I can fit 2 on them. What's the deal? Why is it so big? Well, I optimized it for hand assembly, so it would be more fun to use. But you basically put the antenna in, and then there's an out button, and like I said, I have 1,000 with me. So just for scale, this is how it fits on the Ledger Nano, this is how it fits on the Trezor. It is also, because breadboard friendly is a thing, so we made it breadboard friendly. So you can also play along very easily at home. So then the last challenge with an RF implant is how do you design an antenna to fit in there? And so the big thing there with an SMA connector is the first prototype I did. Experimented with a few antenna designs, but remember it all has to fit inside the Ledger. So that's actually